All right, so this is video 1 of the semester review for 2019. Woo-hoo-hoo. So this first video is just going to do stuff from Unit 5, so it'll be just the first 13 questions. So starting with number 1, we want to determine if these polygons are similar, and if so, we have to write the similarity ratio and statement, and if not, we have to tell why. So with determining similarity, you first have to make sure all of your angles are the same. So with these parallelograms, which they tell us it's parallelograms, we know that these angles would also be congruent to each other. So our angles are all good. And then the other part to it is that your sides have to be proportional. So that means 84 and 60 should have the same ratio as 35 to 25. So you just double check that 84 divided by 60. And notice I picked a number from each shape when I'm doing this because this is going to give me my similarity ratio. And that is 1.4. And then we'll just double check. You do have to make sure all the sides have the same. So 35 divided by 25. Oops, can't type on my calculator. And it also gives us 1.4. So because they have the same ratio between the sides, we know it is indeed similar. So our ratio is going to be 1.4. Or if you want, you can also just simplify the fractions. 35 divided by 5 is 7, and 25 divided by 5 is 5. So it's 7/5 or 5/7, or whatever 5 divided by 7 is, 0.714. So our similarity statement would then be just the letters they give us. And if they tell you the letters, just use the ones they give you. So E, F, G, H is similar to T, W, V, U. And if you have a different order, that's fine, as long as you don't have one of the ones with like a single line like G and like double line like V. As long as you don't have those in corresponding parts, then you're fine. So, and I'll highlight the answers, that way it's a little bit easier. There we go. So then for this one, it is important that we pay attention to the letters because the letters do make a difference. So in this case, CD, these first two letters, which is this one, would correspond to LM. So notice, even though your first instinct is to put 1.5 over 1.7, probably, that is not going to be the case. So then DE, and I'll just circle it so it's a little bit different, is going to correspond to MN. And then 1.4 and 1.7. So when you're doing your similarity ratios to see if they're similar or not, it is important that you always start with the same shape and end with the other shape. So if I start with the shape on the left, I need to always start with the shape on the left. So we'll start with 1.5 divided by 1.6. 1.5 divided by 1.6 is 0.9375. And then we'll do the 2 to 2.3, so 2 over 2.3. 2 divided by 2.3 in the calculator gives me 0.869, blah, 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 blah. And right off the bat, because these numbers don't match, I can just say they're not similar. If you really want to, you can double check 1.4 divided by 1.7. Not that it's going to change our answer, but maybe you did this and you just want to see if it's the same, but you get 823, blah, 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 blah. So since none of these ratios are the same, they are not similar. Side ratios, why can I not write? Side ratios are not equal. Okay. So for 7.2, we are just dilating these. So remember, with dilation, literally all you are doing is multiplying your values by your scale factor. So since my scale factor is 1.5, my dilation would be 1.5x, 1.5y. And I know I don't have that much space, so forgive me for writing ugly. But 4 times 1.5 is 6, so this would give us negative 6. 1.5, because again, we're just multiplying, 2 times 1.5 would give me 3, so that would be -3, 1.5. -2, again, is still -3, but 6 times 1.5 is 4. And then 4 times 1.5, I want to say is 6, yep, I'm right, is -6. And then 6, again, is going to just be 4. So then you plot this on the graph. So -6, 1.5 would be about here. And then -3, 1.5. Boop. -3, 4. Wait a second. That's not right. 6 times. Haha, just kidding. This is 9. I thought that looked funny. Sorry if I messed you up. I accidentally hit divided by instead of multiplied. So 1.5 times 6 is 9. I should have caught that before. I am sorry. So -3 up to 9 would give us boop all the way up here. And then -6 to 9 would be up here. Boop, there we go. If we have a scale factor of 1/2, it is 1/2 x, 1/2 y, or x over 2, y over 2, whatever. That does not look like a y. Mildly better. All right, so half of -6 would be -3, and half of 8 is 4. So if we want, you can even plot it as you go. -3, 4 would be right there. And then 0 times 1/2 is 0. 6 times 1/2 is 3. So we'd have 0, 3. And put a point and connect. And then -4 times 1/2 would be -2. And 2 times 1/2 would just be 1. So -2, 1. Boop, boop. There we go. And that's it. And just one thing to consider is that if your scale factor is bigger than 1, you should be getting a bigger shape. If it is smaller than 1, then it should be making it slightly smaller. So, continuing on, we have 7.3, 3 methods to know or to prove that two triangles are similar. This is AA, similarity, don't forget the squiggles, SAS, similarity, or SSS, similarity. So, remember with SAS and SSS, your sides have to be proportional to help prove it. And that's going to kind of get into play on some of the later ones. So, first off, we need to determine the theorem that proves that triangles are similar based on the information given, and then write the similarity ratio if applicable. Let me see if I can move this real quick. I don't know if it will. It's not. Okay, well, that's fine. But if we look at this, we know that this 100 degrees is the same. And then because two of my methods require side lengths, I know this one has to be angle, but I just have to find the other angle. Even though it might be tempting to say A and E are congruent, they aren't unless we had parallel symbols, which we don't, sadly. But we do have vertical angles. And in your notes packet, there's a bunch of we have the 4 things that you should look out for, like vertical angles, corresponding angles, alternate interior, all that. So you may just want to look back at that. But since we know that these two angles are congruent, we have a similarity, and we have to write the similarity statement. So I would say triangle ABC is similar to triangle A would correspond to E, D corresponds to B, and C corresponds to itself. And we have no similarity ratio because we have no side length. All right. So then, scroll. Oh no, it's thinking really hard. There it goes. So then for number 7, we have JLK corresponds to JMN. So these are going to correspond about how you expect. What I notice here is that I have little angles that are congruent, and then I just so happen to have the sides that are right next to those angles. So chances are it's going to be SAS, and spoiler alert, it is SAS. But remember, with SAS and SSS, we have to have that ratio. So if I go from my small triangle to my big triangle, If I started with the small one, I would have like 12 over 16 because those are the corresponding parts. And 12 divided by 16 is 0.75 or 3/4 if you wanted to simplify. So then to compare the other one, my small triangle's other side is 24 and my long one is the full length. So 24 plus 8, which is 32. So then 24 divided by 32, is also 0.75. So our sides are proportional. They have the same ratio. So we just write our ratio. That is 3/4, or if you want to write it as a decimal, you can. I'm going to accept that. So then for your similarity statement, it's super easy. Use the letters they give you. Triangle JLK is similar to triangle JMN. Don't lose points on triangle names just because you didn't pay attention to how they wrote it. Okay? So then for number 8, we are going to find our corresponding parts first because this one's kind of a doozy. So PQ is here, and it's going to correspond to UT. So just like the other one we did, they don't necessarily correspond to the parts you want them to. So then QR is 1.8. That's going to correspond to TS, and then 3.6 and 6 correspond. So if this works, it's going to be SSS, but we're going to double check real quick. We have 2.1 divided by 3.5. We will also have 1.8 divided by 3 because these are the corresponding sides. Remember, the little shapes help me kind of find it. And then 3.6 divided by 6. So we'll just do this real quick with the calculator. The first one, this gives me 0.6. 1.8 divided by 3 also gives me 0.6. And 3.6 divided by 6 also gives me 0.6. So even though you may feel like, oh, do I really have to check all these? The answer is yes, because it is very possible that only one of them will be off. So because all 3 sides are proportional, we have SSS similarity. Our ratio would be 0.6 or 3/5. If you are good with your fractions, then you can do that. And then our similarity statement, again, use the letters they give you. Don't overthink it. Triangle PQR is similar to triangle UTS. All right. And so then moving on to 7.4. Boop, come on. Oh no, it's thinking again. Yay, it's working now. All right, so for 7.4, it was all about different theorems we had. So looking at the triangle proportionality theorem, all that theorem says is that when you have parallel lines in a triangle, which first off, it is really just one big triangle, and then with that big triangle, they drew a parallel line through it. Okay, so that's first off the easiest way to see it, because if you see it like that, you can actually make your life a little bit easier, because the theorem basically just says when you cut it with that parallel line, which like I showed you with the highlighter, it's just that one. But when you cut it, it is cutting that triangle proportionally. So the relationship between x and 9 is going to be the same as 15 and 9. So just like you were doing before, you're going to set up a proportion. You're going to set up the ratios, and then you're just going to set them equal to each other. So normally I would tell you to go, 9 to 15. So we'd have 9 over, actually, this is one of the ones that you can set up a bunch of ways. You can set it up as 9 over x equals 15 over 9. Notice that in this case, my corresponding ones, the ones that I circled, are on one side, and the one I boxed are together on one side. You can either set it up like that, or you can set it up as 9 over 15 equals x over 9, because then you have your corresponding pieces on the same side in the same area. So either way will work. Notice that they're still multiplying the same stuff. But just know when you're setting up these proportions, either corresponding parts on the same side, like on the left, or corresponding parts on the same in the same spot on opposite sides. So the 9 was on the top, the x is on the top. But for the sake of simplicity, I'm going to get rid of my extra stuff, and I'm going to erase this, and I'm going to actually solve it now. So we have to cross multiply. So we would have 15x equals 81. And then to finish this, is going to let me scroll a little bit because I just want a baby, just so I can write 15. When we divide by 15, 81 divided by 15 is 5.4. Okay, and BH is our X value, so we just get to write 5.4 units. Okay. So then for this one, again, we have our triangle, and then somebody came through and cut it with a parallel line. So then I know these pieces are proportional. So since I'm looking for MV, that's right here. To get the value of VN, you can do 49 divided by 49 minus 14, which is 35. Or you could also solve this by looking at the full side. So just like before, corresponding parts are here and here. Now, just to show you the other way, I'll do it afterwards, actually. I don't want to confuse anyone. But corresponding parts, sorry if that was really loud, by the way. 8 over 14 equals x over 35. That will work. Now, if you are on the side of, I just want to add my sides and see it as two separate triangles, then you would set it up as x over x plus 8 equals 35 over 49. Or at least that's one way you could set it up. And if you're not sure if your way works, just know that if you set it up incorrectly in any way, shape, or form, your answer will not be right. So to take the simpler route, we get rid of this. We're just going to use the 8 over 14 equals x over 35. Again, my corresponding stuff is on the same side. If you want, they can be on opposite and just same area. But this gives us 14x. That equals 8 times 35 is 280. So then when we divide by 14, we get that x is 20. So MV is 20. Yay! And if you want units, go boy swim. Woo! All right. So then triangle angle bisector theorem is basically the same, except now, and we'll use dark blue this time just for fun, now you just have to see it as two separate triangles because this angle is bisected, so you're looking at the triangle on the left and the right, top, bottom, however it's drawn. But just like before, you can put corresponding stuff on the same side. So like 144 over 108 equals 7x over 5x plus 2. Or you can put same stuff on opposite sides. And just like before, when you were doing your similarity ratios and everything, if you start with 144, then your other ratio has to start with 7x because they're in the same triangle, so to speak. So that would give us 144, and actually I'll just set this up a different way. We'll do 144 over 108, so corresponding, oops, no, I want them on opposite sides, silly. Oopsie. So 144 over 7x equals 108, corresponding piece, over the other corresponding piece, 5x plus 2. So then we will have to cross multiply, and this is where you have to be careful because it's 144 times the entire thing, 5x plus 2, equals 7x times 108, which I guess I could have actually done that one. Oh well, only live once. So 144 times 5x gives us 720x, and then 144 times 2 is 288. And then 7x times 108 is 756x. So I notice I have x's on both sides. I'm going to go ahead and just move that 720x over. Oops, that looks like a z. 720x, there we go. So then I have 288 equals 756 minus 720 is 36x. And then we divide by 36. To get that x is 8. So now that I have this value for x, I'm going to have to use that and plug it in. So for SR, that would be 8 times 7. So that would be 56. For RQ, that would be 5 times 8 plus 2, and 5 times 8 is 40, plus 2 is 42. Okay, so then to set it up with the next one, we would have 2.5, which corresponds to 2y minus 0.25, and then 2 and y plus 0.25. So to set it up, if I wanted to put my corresponding stuff in the same spot on opposite sides, you can. Oops, minus. And then that's 2 and y plus 0.25. All right, so again, my corresponding parts are just in the same spot, opposite sides. Again, you could also set it up with them on the same side together if you want. So when you cross multiply, we would have 2 times 2y minus 0.25 equals 2.5 times y plus 0.25. So distributing, we would have 4y minus 0.5 equals 2.5y, oops, 2.25, plus 0.625, and I would just leave it like that for now. So I would subtract the 2.5y first, because that gives us 1.5y minus 0.5 equals 0.625. And then when we add that 0.5, we get 1.5y equals 1.125. And that divided by 1.5 tells us that y is 0.75. So then, because we know y is 0.75, we come back over here and plug it in. So BE is 2 times 0.75 minus 0.25. So 0.75 times 2 minus 0.25 is 1.25. And then, oops, DE is going to be 0.75 plus 0.25, which means DE is just 1. Okay. Man, it's sinking really hard. There it goes. All right, and then last but not least is the similarity ratios for these. So keep in mind, your rule is that if you have a side ratio, your perimeter is the same as it. So same as side ratio. And if you have area, it's your side ratio squared. A lot of people forgot that rule, so just make sure you are aware of it. I remember it, just that perimeter is the same, and area is the same as what you do to the units when you find area, because it's meters squared, so it's your side squared. So first, getting a side ratio for this, literally, I just always go from whichever one has the labels in it to the other one. So this one, in this case, goes from big to small, so 90 divided by 60. I would personally simplify as much as you can because it makes your life simpler, so that would be 9 over 6, which then becomes 3 over 2. So this is the side ratio. Oops, went all crazy for a second. Side ratio. So since that is the side ratio, we're going to be using it for both. Doing perimeter first, that would be 3 over 2. Remember, it's the same. So my side ratio is my perimeter ratio, and that's going to be equal to the perimeter of my big one, because I started with the big one, over my unknown perimeter of my little one. So then we just cross multiply. So 3p equals 381 times 2, which gives us 762. And when we divide by 3, we get that p, is 254 meters. Okay. So then for area, you're going to do the exact same thing, except instead of just leaving it as 3 over 2, you're going to have 3 over 2 squared because the ratio is squared. And then on the other side, you will put your actual area for your big one, because that one was the one we did first, over your unknown area. So 3/2 squared would be 9/4. And then we cross multiply. So we'd have 9a equals, that multiplication gives you 7,776. And then when we divide by 9, we get that a is 864. So this would be 864 meters squared. So that concludes the Unit 5 quick review on the semester review. If you have any questions, please feel free to ask. Otherwise, watch the next video so that you can get the next unit's stuff. Happy studying!